Welcome to my new video. This is section 6.2, slopes of parallel and perpendicular lines. What do railway tracks, ladders, and streets in the section have in common? They all involve lines. Some lines never meet. Some lines meet at perfect right angle. So in this lesson, we learn how slope helps us identify parallel lines, perpendicular lines, and by the end of the video, you will be able to solve all examples from section 6.2, and also you will be able to solve the practice question from section 6.2. So let's get started. So first we are focusing on the slopes of parallel lines. Here you can see two parallel lines. AB is a line and CD is another line. So I have chosen two different points on each lines to calculate the slope. Over here you can see the rise is 6 and the run is -3. So slope of AB, rise is 6, run is -3. 6 over -3. I can simplify this, that is 6 by 3 is negative. Next we are going to calculate the slope of CD, and here the rise is 4, run is -2. Slope of CD, that is rise is 4, run is -2. 4 divided by -2, we will get -2. See here, slope of AB is -2, slope of CD is -2. And we know that they are parallel lines. So parallel lines have the same slope. Here we are going to apply the concept of parallel lines in this assignment. Question number 1. The question 1 is the slopes of lines are given. Circle the slopes of parallel lines. See, first of all, we know that parallel lines have same slope. So it should be either both positive or both negative. So here we have two negative numbers, -5 over 3 and -3 over 5. Okay, 5 by 3 and 3 by 5. Of course, they are different numbers, different ratios. So they can't be parallel lines. Remaining, we have 5 over 3 and 10 over 6. This one and this one, 5 over 3 and 10 over 6. Do you think that are the same? Yes, they are. You know why? 10 over 6 is technically equal 5 over 3, because you can divide 10 divided by 2 divided by 2. So 10 divided by 2 is 5. 6 divided by 2 is 3. So 10 by 6 and 5 by 3 are equivalent fractions. So if we have equivalent fractions or same numbers, they must be parallel lines. Now we are looking at the example number 1, identifying parallel lines. You have three pairs of coordinates, E and F, P and Q, R and S. Our question is, are the lines parallel? So our first step is we are going to verify this graphically. So you have to graph the lines, plot the respective coordinates. E is -4, -3, 0, 3. P -3, -5, 2, 3. And this is R is 0, -3, S is 4, 3. And join the lines. And you can see that all of them appears to be parallel, but still we are not 100% sure whether they are parallel or not. If your diagrams almost look like appears to be parallel, for example, when you're drawing the lines, one of the line is like this, the other line is like this, then you don't need to check it mathematically, because it is not appears to be parallel. So you don't need to do that question further. But at the same time, if one of the line is like this, the other line is also like this. Okay, so these two lines are almost appears to be parallel. In that case, we have to verify it mathematically. So what I'm going to do, we have to calculate the slope of each coordinate pairs. We have already learned this method in the last section. So use this formula. This is x1, y1, x2, y2. So rewrite the terms x1, y1, x2, y2 and substitute the terms over here. And if it is a fraction, make sure that you are writing the simplest form of the equivalent fraction. Repeat the same step for the remaining pair of coordinates, PQ and RS. Now we can compare the result. Here, the slope of EF is 3 over 2. Slope of PQ is 8 over 5. And slope of RS is 3 over 2. So it is evident that these twos are same, which means the slope of EF and RS are equal. So these two lines are parallel. Although PQ appears to be parallel, but it is not. By looking at this, the graph, you can see that this PQ is also appears to be parallel, but unfortunately it is not parallel to EF and RS. So we have to verify it mathematically all the time. So your question 5 in your assignment is based on example number 1. You have two pair of coordinates. So first you have to graph the line and state whether they appears to be parallel or appears not to be parallel. And after that, use the formula of the slope and calculate the slope of AB, calculate the slope of CD, and finally compare the result whether they are equal or not. Okay, so slope of AB and CD are equal or not equal, so the lines are parallel or not parallel. Now we can check an example from page number 326. So here you can see two lines. PQ is a line, RS is another line, and these two lines are perpendicular. So let's calculate their slope. Using the same method, rise over run, and the slope of PQ is 2 and slope of RS is negative 1 over 2. Here 2 and negative 1 over 2 are called as negative reciprocals. So first of all, before explaining what is negative reciprocal, let's look into the concept of reciprocal. Reciprocals. For example, if we have a number, any whole number, 3, we know that any whole number can be expressed as a fraction with a denominator 1. So 3 is mathematically 3 over 1. That 1 is invisible there. So when you're writing the reciprocal, the important step is you have to switch the numerator and denominator. So the reciprocal of 3 is 1 over 3. One more example. Reciprocal of 10 is 10 means 10 over 1. So the reciprocal is 1 over 10. In one more example, reciprocal of 3 over 5. 2 by 3 will be 3 by 2. So here I'm talking about just the reciprocal. Okay. But we need to know what is negative reciprocal. Negative reciprocal. What is that? Okay. The concept is very simple. Negative reciprocal means one of your reciprocal must be negative. For example, this pair 3 over 1 and 1 over 3. I am taking one of the number is negative. So 3 and negative 1 by 3 are negative reciprocal. Okay, so this pair 10 and 1 by 10. So suppose negative 10. Negative reciprocal of negative 10 is positive 1 by 10. Or negative reciprocal of 10 is negative 1 by 10. Okay, look at this example. Suppose this is negative and this one is positive, then we can say they are negative reciprocals. 2 by 3 and 3 by 2. Let this be negative. Okay, so they are negative reciprocals. So any one of the pair should be negative. So now we can check this. We have 2 here. 2 means 2 over 1. So reciprocal of 2 is 1 over 2 and the negative reciprocal of 2 is negative 1 over 2. And one more thing, when you're multiplying the reciprocal, negative reciprocal, and the product will be negative 1. Let's check. 2 times negative 1 half equal negative 1. You can verify with this your calculator. So we can say negative half is the negative reciprocal of 2 and they are perpendicular. So this is the theorem. The slope of two oblique perpendicular lines are negative reciprocal. That is, the line with slope m and the perpendicular to the line with a slope is negative 1 over m. You can use this concept to solve the question number 2. So the slopes of lines are given. Circle the slopes of perpendicular line. That's the question. So remember, perpendicular lines means one of the numbers should be negative. So here I have 3 positives. This is positive, this is positive, this is positive. And I have only one negative number, which means one of the numbers should be negative. Okay, so I am taking this one, negative 5 over 8. And you have to calculate the negative reciprocal of negative 5 over 8. So 5 over 8 become 8 over 5 without negative sign. So this is the negative reciprocal of negative 5 over 8. So these two lines are perpendicular. So apply the same knowledge over here for answering the question number 3. A line has a slope negative 3. Write a perpendicular line. So you have to write the negative reciprocal over here. Then a line CD has a slope 3/4 and the perpendicular to CD, again write the negative reciprocal. Again perpendicular of EF, write the negative reciprocal, write the negative reciprocal of 1. What is the reciprocal of 1? I told you any whole number can be written as fraction with the denominator 1. Okay, so 1 is mathematically 1 over 1. That 1 is denominator 1 is invisible here. And the reciprocal is switching the numerator and denominator 1, 1. Okay, so reciprocal of 1 is 1 itself. So negative reciprocal of 1 is one of the numbers should be negative. So negative 1. Question number 4. We are applying the concept of parallel and perpendicular theorem together here to check the following pairs are parallel, perpendicular or neither. So compare the pairs. If they are equal or equivalent fraction, they must be parallel. And if the given pair is negative reciprocals, then they must be perpendicular. And if it is not following any of these conditions, then there is neither parallel nor perpendicular. Question 6 is based on example number 2. You can see pair of coordinates. Okay, so first task is graph the line over here. Okay, identify the coordinates on this grid and say line QR and ST appears to be perpendicular or appears to be not perpendicular. Okay, so after drawing you have to make the conclusion and find the slope to check. Use the formula y2 minus y1 over x2 minus x1. Substitute the corresponding value and find the slope over here. Okay, the simplest form of your slope. And repeat the same procedure for ST and the corresponding slope. Now you have to multiply these two slopes, this one over here. And if you are getting negative 1, then you can say the slope of QR and ST are negative reciprocals. So the lines are perpendicular if you are getting negative 1. If you are not getting negative 1, there must be some mistakes, so you have to recheck it again. So that's everything for this lesson, and we will see you on the next video. Thanks for watching.